Welcome back guys. In this video we are going to check out HTTP in detail room from TryHackMe. In this room we will learn about how you request content from a web server using the HTTP protocol. Okay, let's move to the task number 1. What is HTTPS? What is HTTP? Hypertext Transfer Protocol. HTTP is what's used whenever you view a website. Developed by Tim Berners-Lee and his team between 1989 and 1991. HTTP is the set of rules used for communicating with web servers for transmitting of web page data, whether that is HTML, images, videos, etc. What is HTTPS? Hypertext Transfer Protocol Secure. HTTPS is the secure version of HTTP. HTTPS data is encrypted, so it not only stops people from seeing the data you are receiving and sending, but it also gives you assurance that you are talking to the correct web server and not something impersonating it. Now let's answer the questions. What does HTTP stand for? Hypertext Transfer Protocol. What does the S in HTTPS stands for? It is secure. On the mock web page on the right, there is an issue. Once you found it, click on it. What is the challenge flag? Let's check out the site. On the mock web page, there is an issue. Okay, let's see. It is using HTTPS. Okay, an embedded page. You got the flag. Invalid HTTP set. Let's copy it and paste it. Let's move on to the task 2. Requests and responses. When we access a website, your browser will need to make requests to the web server for assets such as HTML, images, and download the responses. Before that, you need to tell the browser specifically how and where to access these resources. This is where URLs will help. What is a URL? Uniform Resource Locator. If you have used the internet, you have used a URL before. A URL is predominantly an instruction on how to access a resource on the internet. The below image shows what a URL looks like with all of its features. It doesn't use all features in every request. So we have a scheme, user, host or domain, and the port number, then path and query string, and an optional fragment. Scheme. This instructs on what protocol to use for accessing the resources, such as HTTP, HTTPS or FTP, which is File Transfer Protocol. Next, user. Some services require authentication to login. You can put a username and password into the URL to login. Host. The domain name or IP address of the server you wish to access. Then port. The port you are going to connect to, usually 80 for HTTP and 443 for HTTPS, but this can be hosted on any port between 1 to 65535. Path. The file name or location of the resource you are trying to access. Then query string. Extra bits of information that can be sent to the requested path. For example, /blog id equal to 1 would tell the blog path that you wish to receive the blog article with the ID of 1. Next, fragment. This is a reference to a location on the actual page requested. This is commonly used for pages with long content and can have a certain part of the page directly linked to it, so it is viewable to the user as soon as they access the page. Okay, making a request. It's possible to make a request to a web server with just one line, that is get HTTP 1.1. Okay, So the request method, the get is the request method, and the HTTP 1.1 is the HTTP protocol version. But for much wider web experience, you will need to send other data as well. This other data is sent in what is called headers, where headers contain extra information to give to the web server you are communicating with. But we will go more into this in the header task. So this is an example request. We can see the request method, host, user agent, and referrer. To break down each line of this request, the line 1, this request is sending the get method request to home page with slash and telling the web server we are using HTTP protocol version 1.1. Line 2, we tell the web server we want the website tryhackme.com. Line 3, we tell the web server we are using the Firefox version 87 browser. Then line 4, we are telling the web server that the web page that referred us to this one is tryhackme.com. And then line 5, HTTP requests always end with a blank line to inform that web server that the request has finished. So for an example for any response. So here we got a response of HTML code. So if we break down this response, we can see the HTTP 1.1 is the version of the HTTP protocol the server is using, and then followed by HTTP status code 200 OK, which tells us the request has completed. You can see the 200 OK, and then the server is engines with the version 1.15.8, and the date of the response is this, and the content type that was requested is text HTML with the length of 98, and the lines 7 to 14 is the information that has been requested, in this instance the home page. Now let's answer the questions. What HTTP protocol is being used in the above example? In this example, what is the HTTP? It is 1.1. What response header tells the browser how much data to expect? It is content length. Now let's move on to task 3, HTTP methods. HTTP methods are a way for the client to show their intended action when making an HTTP request. There are a lot of HTTP methods, but we will cover the most common ones, although mostly you will deal with the get and post method. Okay, get request. This is used for getting information from a web server. Post request. This is used for submitting data to the web server and potentially creating new records. Put request. This is used for submitting data to a web server to update information. Delete request. This is used for deleting information records from a web server. Okay, get, post, put and delete. Now let's answer the questions. What method would be used to create a new user account? So we can see to create new records we should use post. What method would be used to update your email address? To update any information we are going to use put. What method would be used to remove a picture you have uploaded? It would be delete. What method would be used to view a news article? It would be get. Let's move on to task number 4, HTTP status codes. In the previous task, you learnt that when a HTTP server responds, the first line always contains a status code informing the client of the outcome of the request and also potentially how to handle it. These status codes can be broken down into 5 different ranges. 100 to 199 information response. These are sent to tell the client the first part of the request has been accepted and they should continue sending the rest of the request. These codes are no longer very common. And next 200 to 299 success. This range of status codes is used to tell the client the request was successful. 300 to 399 redirection. These are used to redirect the client's request to another resource. This can be either to a different web page or a different website altogether. 400 to 499 client errors, used to inform the client that there was an error with their request. 500 to 599 server errors. This is reserved for errors happening on the server side and usually indicate quite a major problem with the server handling the request. So we will mostly see the 200 to 299 range and 400 to 599, these two ranges. Common HTTP status codes. There are a lot of different HTTP status codes, and that's not including the fact that the applications can even define their own. We will go over the most common HTTP responses you are likely to come across. So 200 OK. The request was completed successfully. So whenever the request is successful, the server will respond with 200 OK. 201 created. A resource has been created. For example, a new user or a new blog post. Next 301 moved permanently. This redirects the client's browser to a new web page or tells search engine that the page has moved somewhere else and to look there instead. 302 found. Similar to the above permanent redirect, but as the name suggests, this is only a temporary change and it may change again in the near future. 400 bad request. This tells the browser that something was either wrong or missing in the request. This could sometimes be used if the web server resource that is being requested expected a certain parameter that the client did not send. Okay. 401 not authorized. You are currently allowed to view this resource until you have authorized with the web application, most commonly with a username and a password. Next 403 forbidden. You do not have permission to view this resource whether you are logged in or not. 405 method not allowed. The resource does not allow this method request. For example, if you send a GET request to the resource /create account when it was expecting a POST request instead. And then 404 page not found. The page or the resource you requested does not exist. And then 500 internal server error. The server has encountered some kind of error with your request that it does not know how to handle properly. Then 503 server unavailable. This server cannot handle your request as it's either overloaded or down for maintenance. Click the view site button on the right to see what some of these HTTP status messages look like in a browser. Okay, now let's answer the questions. What response code might you receive if you created a new user or blog post article? It would be 201 created. What response code might you receive if you try to access a page that does not exist? It is 404 page not found. What response code might you receive if the web server cannot access its database and the application crashes? So if the web server cannot access its database, then that means the range would be from 500 to 599. So internal server error would be the server has encountered some kind of error with your request. And 503 is server cannot handle your request as it's overloaded or down for maintenance. Okay, now what response code might you receive if the web server cannot access its database? That means it is 503, service unavailable. What response code might you receive if you try to edit your profile without logging in first? Then it would be not authorized 401. Okay. So these are some of the examples for 403 forbidden error page, 404 not found, and we would also get the server details, and for 503 we can see that it is service unavailable, and we will also get the same information of the server. Let's move on to the next task. Headers are additional bits of data you can send to the web server when making requests. Although no headers are strictly required when making a HTTP request, you will find it difficult to view a website properly. Common request headers. These are headers that are sent from the client, usually your browser, to the server. Host. Some web servers host multiple websites, so by providing the host header, you can tell it which one you require, otherwise you will just receive the default website for the server. User agent. This is your browser software and version number. Telling the web server your browser software helps it format the website properly for your browser, and also some elements of HTML, JavaScript and CSS are only available in certain browsers. Next, content length. When sending data to a web server, such as in a form, the content length tells the web server how much data to expect in the web request. This way the server can ensure it isn't missing any data. Accept encoding tells the web server what types of compression methods the browser supports, so the data can be made smaller for transmitting over the internet. Then cookie. Data sent to the server to help remember your information. Okay, now common response headers. These are the headers that are returned to the client from the server after a request. Set cookie. Information to store which gets sent back to the web server on each request. Then cache control. How long to store the content of the response in a browser's cache before it requests it again. Content type. This tells the client what type of data is being returned, that is HTML, CSS, JavaScript, images, PDF, video, etc. Using the content type header, the browser then knows how to process the data. Content encoding. What method has been used to compress the data to make it smaller when sending it over the internet? Okay, now let's answer the questions. What header tells the web server what browser is being used? It is user agent. What header tells the browser what type of data is being returned? Content type. What header tells the web server which website is being requested? Host. Now let's move to the task 6, cookies. You've probably heard of cookies before. They are just a small piece of data that is stored on your computer. Cookies are saved when you receive a set cookie header from a web server. Then every further request you make, you will send the cookie data back to the web server, because HTTP is stateless, that is, it doesn't keep track of your previous request. Cookies can be used to remind the web server who you are, some personal settings for the website, or whether you have been to the website before. Let's take a look at this as an example HTTP request. So this is a example HTTP request. The client requests web page from cookies.thm. Then the server responds back with a simple web page with a form asking for user's name. The client sends back the form with the name set to Adam. We can see here. Now the server responds with the set cookie header telling the client to save the data name equals to Adam. So the server responds with setting the cookie name. On the next and every further request, the client sends the cookie data back to the server. The client sends cookie data back to the server for every request. Then the server then sees the cookie data, and instead of displaying the form, it displays a welcome back message instead. Cookies can be used for many purposes, but are most commonly used for website authentication. The cookie value won't usually be a clear text string where you can see the password, but a token, a unique secret code that isn't easily humanly guessable. Viewing your cookies. You can easily view what cookies your browser is sending to a website by using the developer tools in your browser. If you are not sure how to get to the developer tools in your browser, click on the View Site button at the top of this task for a how-to guide. Once you have developer tools open, click on the Network tab. This tab will show you a list of all the resources your browser has requested. You can click on each one to receive a detailed breakdown on the request and response. If your browser sent a cookie, you will see these on the Cookies tab of the request. Let's check out. Okay, so this is just an instruction for viewing developer tools. So if we reload this page, we can see all the data requested and all the response we get. Now let's answer the question. Which header is used to save cookies to your computer? It is set cookies. Now let's move to the task number 7. Making request. Click on the view button on the right. This is an emulator for making demo HTTP request. Using what you have learned from the above tasks, you can use it to complete the below questions. Okay. Okay, here we can change our methods. Here we can edit our URL, send request, okay, parameters, okay. Now let's answer the question. Make a get request to /room. Okay, we got the flag. Make a get request to blog, and using the gear icon set the ID parameter to 1 in the URL field. ID parameter to 1. ID 1. Now let's send the request. Yeah, we got the flag. Next, make a delete request to the user/1. Okay, delete request to user1. Okay, let's paste this flag. Make a put request to user2 with the username parameter set to admin. Okay, put request to the user2 with the username set to admin. Okay, let's send the request. Username has updated. Okay, and the last question, post the username of THM and a password of let me in to /login. Okay, it is a post request and the URL is login and the parameters are username. Okay, let's edit here. Username is th. Okay, we have to add new ones. Username thm and then password let me in. Now let's send the request. We got logged in. Cool. Okay guys, thank you for watching this video. If you like these type of walkthrough videos, check out my other stuff.